Welcome back once again. This is the third and last video of our Secure Workload and Secure Firewall integration series. In this video, we will showcase a Zero Trust Segmentation Demo using this example scenario architecture, and we will be emulating operations-like requirements and tasks done in enterprise environments. So let's take a look. Let's set up the stage for the Zero Trust Segmentation Demo. We have an invoice app which is hosted on premises. Important note to mention is that there are no agents installed on the workloads. InfoSec reached to us due to some security requirements and compliance initiatives ongoing. First and foremost, they require us to have a zero trust policy approach, and for this they require the following. That the sales users can only have access to the web tier of the application. We need to allow developers web tier, management tier, monitoring tier, and database tier for the invoice application. We need to revoke contractor access to the web tier of the application. We need to make sure that no IoT device have access to the production applications. And lastly, that InfoSec recently detected a vulnerability in some Microsoft SQL servers, and they currently don't have the time to patch them. So they requested us to minimize the risk while they get an approved patch window. They stated it's okay to perform a virtual patch. Just to note out that we're using Identity Service Engine for identity mapping. So let's jump into our environment. And here we are in our Secure Workload UI. We navigate to Defend Segmentation, and we will proceed to create our application workspace. In this case, it will be for the invoice app. We select the scope of the application, and we create the application workspace. As you can see here, there are no policies defined whatsoever. We will automatically discover them. Now, if we navigate to Matching Inventories and look under the Workload tabs, you will see that there are no workloads with agents. We only see IP addresses. So with this, we confirm that this is an agentless application. Now, let's navigate to the Start ADM Run tab. The ADM Run stands for Application Dependency Mapping, and here we will configure the time where we want to automatically discover our segmentation policies. So we select this time range, and for the other defaults, I will just leave them as default ones. So I will just click here, Submit ADM Run, and it's starting to run the ADM. While this is ongoing, let's check the environment. Let's check how it looks like. So our first user is Bob. Bob is the contractor, and as you can see here, Bob is able to access the web tier of the application. This is something that the InfoSec team requested us to revoke. The second user is Alice. Alice is from the sales team, and as you can see here, Alice is connected through a VPN connection, and Alice is able to access the web tier of the application. Now, not only this, right? If we explore a little bit more, Alice is also able to access the monitoring tier of the application, which for a sales user is something that we don't really want to have. The last user is Chuck. Chuck is from the development team, and as you can see here, Chuck has access to the web tier of the application. He has full access here, and he also has access to the monitoring tier of the application. Now, this makes sense because he's a developer. He wants to check how the health services for these applications are running. He also has access to the database tier of the application, as you can see, because again, he's a developer. He wants to check how, what is the current health status of our environment to check that everything is okay. The last one here is the IoT device in our branch. And as you can see here, this IoT device is able to have communication with our application in a data center, and this is something that we must block. So we navigate to our Firewall Management Center. We see that we have here a transparent firewall. It's currently running Snort 3 as well. Now we navigate to Objects, Objects Management, then to External Attributes and Dynamic Objects. And you will see here that pretty much there are no dynamic objects created yet. It's almost empty. Now, if we navigate to Policies and Access Control, we check that this is the current policy in place, right? This policy is used by the firewall. And if we click on Edit, we will see something interesting. So the integration is already happening, right? That's why we see these golden rules pushed by secure workload that are basically for the agent to communicate to the secure workload cluster no matter what. And we also see the manual rule at the bottom of our policy, right? So we have here the merge option, which is honoring the current rules configured on the Firewall Management Center. Now let's go back to devices and let's also double check how is our ADM running. So results are available. We can see here that there are some policies already automatically created. But before exploring the policy, let's check the canvas. The canvas is a nice graphical way of checking how the policies look like. And we can see here how our application interacts with external dependencies and with the users, right? We can see how the sales users are accessing both the web tier of the application and the monitoring tier, right? They are accessing the front end HA proxy DB and front end HA proxy respectively. The contractors as well are accessing the web tier, which is the front end HA proxy, and the developers have access to the entire tier of the application. On the external dependencies, we can see as well how the application is interacting, in this case with Active Directory and DNS services. And we can see how the application interacts within itself, right? The intra-application traffic. We can see how the HA proxy DB, the app tier, the HA proxy web tier, and the DB tier interacts within the application. Now let's check our policies. In our policies, you can see this graphical way detailed out in a policy list how the application is accessing the external services such as DNS in this case, how developers are accessing the app tier through SSH. Now, something interesting with developers, as you can see here, the filter is dynamically looking for authenticated users. So only authenticated users will be allowed to access this application on port 22. We can see here the intra-app communication from the HA proxy to the app tier. We can see as well developers accessing the DB tier through MySQL port. We can see more intra-application communication as well. For example, the monitoring here and DB tier. And now we start looking for some interesting rules, right? We can see here that we have users from this scope, from the EMER scope, accessing the application. We don't want this, right? We only want sales users, authenticated sales users, to access our web tier, as well as authenticated developers. So we proceed to remove these two rules here because, again, we don't want unauthenticated users. We see the following rule is the developers accessing the front-end HA proxy, which is okay. We see here contractors, right? Even though the contractors are authenticated, we don't want this, right? Remember, InfoSec requested to revoke this access, so we proceed to revoke it. We finally see here the sales users, and again, a dynamic query looking for authenticated users. So we keep this. We see another rule here coming from the EMER scope. Unauthenticated users, again, accessing the application. We don't want this kind of access, so we proceed to revoke this. And finally, we can see that we have the sales users, right, accessing the monitoring tier of the application, even though they are authenticated, right? They're authenticated sales users. We don't want this type of access for them, right? They're sales users. They're not supposed to access the monitoring tier of our application. And this over here is a Zero Trust Allow List policy model. And this is what we will enforce on the firewall. So we proceed on the enforcement tab, click enforcement policies. So we can see there are no inventory workloads here because it's an agentless application, and we proceed to enforce this. So you can see here is enforced. Now, another requirement from the InfoSec team was about some vulnerabilities, right? So we proceed to create another application workspace. In this case, we call it InfoSec, but in a higher, in a hierarchical way, in a higher way. And as you can see, there are no policies defined here, but instead of defining default policies, we will create absolute policies on this. Because remember, these are business intent policies. These are the intent is to apply it data center wise. We can see here that we have an inventory filter looking for workloads with these vulnerabilities, and we want to block this access from these workloads to the internet, right? So we want to perform a virtual patching on this. So we proceed to create rules to block TCP, UDP, and ICMP for these specific workloads with this vulnerability trying to access the internet. Now, there was also another requirement, and this was about IoT devices. So we have an inventory filtering for IoT from the branch, from our branch locations, and we want to block this access going to the production applications, right, in our data center. So we proceed to create the rules denying the access from these IoT devices to our production scope. And as you can see here, this is the business intent, right? These are the policies that are on a macro level. Now, it's important to mention that because this is on a higher scope, the catch-all policy must be allowed, right? Because we don't want to block access to all of them. We just want to block this specific access for these workloads. So we proceed to do the enforcement here. You can see here the workloads that will be affected, and we proceed to enforce this. Now, before going to the firewall, I want to showcase something here important about the policies. And it was about the dynamic query that is being used. For example, for the CVE1, we can see here that it's looking for specific workloads that contain that vulnerable package. And we can see the workloads that are already identified. So these workloads will not have internet access. On the second inventory filter, we can see that this is a dynamic query coming from ICE, right? So we are querying ICE, we're getting informations for endpoints which contain the IoT security group tag. So these devices that are IoT devices are dynamically updated from ICE to secure workload, and we want to block this access. Now, navigating to the Firewall Management Center, let's check how our dynamic objects look like. Navigating to objects, objects management, and dynamic objects, and you can see here, right, how secure workload dynamically pushed all of these dynamic objects on Firewall Management Center, and they are updated dynamically as well. So if any of these objects, for example, gets a new workload, it will be updated directly from secure workload to Firewall Management Center. And in our policy, we can see as well that the policy has been modified by the REST API user from secure workload. Let's explore the policies. And under the policies, we can see how the very first policies are the business intent, right? This mandatory compliance requirement from the InfoSec team blocking the vulnerable workloads and the IoT devices. And then just after those, we have our allow list zero trust policy for our agentless application, right? So we can see how secure workload keeps the intent, right? Keeps pushing these macro policies for defense in depth, and is also able to do segmentation for agentless application. Now on the deployment tab here, I want to showcase something important, that deployments will only happen when there is a change in policy. If an object gets updated automatically, this will not require a new deployment. It will only require a deployment if there is a policy change. Now, let's verify in our environment like. Let's see how it looks like now. Let's first start with Bob. Bob is a contractor. So Bob, if we see here again, is not able to access our web tier, right? So we effectively revoke Bob access to the web application. Now let's check Alice. Alice is the sales user. So she should still be able to access the web tier of the application. And we can see that indeed she is. She is still able to access the web tier. But let's verify about the monitoring tier. And now we correctly see that she doesn't have any more access to the web, to the monitoring tier of the application. Let's check Chuck. Chuck is the developer. He must have access to all tiers of the application, so let's verify. And here we can see that he's able to access the web tier of the application, as well as the monitoring tier of the application. Now let's verify the database tier, right? We're still missing that tier. And we can see here that Chuck is able to access the database tier of our application, so he still retains his current access, so no breaks in the user experience. Finally, let's check the IoT device. And on the IoT device, we can see that the IoT device is not longer able to have connectivity with our data center applications. So we effectively uh, completed and achieved all the requirements from our InfoSec team in this Zero Trust segmentation demo. So I want to thank you for viewing this and see you next time. Thank you.